Balancing chemical equations is going to be so much easier after you understand all of the rules, and of course, I'm going to teach you some of my tricks. So balancing chemical equations, this is going to be very important, I'd say, to do for basically the entire semester. You're going to be doing stoichiometry after this, which we have seen a little bit of that already with Avogadro's number, moles, and so on. But you're typically going to have a balanced equation to be able to work out those stoichiometry word problems. So it's not as bad as it looks. Essentially, it really isn't. Once you get the hang of it, you're going to get really fast at it. I know. I mean, you've gotten 2 A's in a row. I don't doubt you. So the main thing is with balancing equations is it's literally what it sounds like. We want to balance out this reaction, meaning we want to have an equal amount of the same elements. Like in this case, we have to have, if iron has 2 on one side, it has to have 2 on the other side. So both of them have to have the same amount of irons, of oxygens, of sulfurs, and so on. And this is how we're going to do this. So how I personally like to start off balancing equations is by literally writing out how many of each element I have on either side. So I'm going to literally just kind of write out, all right, well, these are all the elements that I have. And I'm going to count up how many I have on each side. As a little rule of thumb, I always leave oxygen for the very last to balance out. It's just because it tends to work out better. Oxygen, if you start off with that, it's, I don't know why, but it's always kind of been a thing where it gets more complicated because oxygen is typically in multiple places, as you see now. So that's just a tip. So I'm just going to start off with counting how many iron, sulfurs, and oxygens there are on the reactant side. So I know that there's no subscript on iron, so that's going to be 1. I have a 2 subscript that's telling me that there are 2 sulfurs, and a 2 subscript telling me that there are 2 oxygens. Now I'm going to do the same thing for the product side. So I know that iron, there's a 2 subscript, meaning there are 2. There's only 1 sulfur since there's no subscript. And then I have to make sure to count this. So this is one little thing. Always double check. Don't just say, oh, there's 3 oxygen and be done with that. Yep, I know. This is how it'll get you. So we want to add everything, all the oxygens that we have. So 3 plus 2 gives us 5 oxygens. Okay, so next we're going to practice just balancing everything out. I'm going to start off with just the iron. So if I have 2 irons on this side, then I want to have, 2 irons here. So what I'm going to do is simply put a 2 coefficient in front of the entire compound. So another thing to note is we are not allowed to separate the compound, meaning I can't, if I wanted, I know you wouldn't do it for this, but if I wanted to put a 2 just in front of the sulfur, I am not able to do that. It has to be in front of the entire compound. We cannot separate that. So instead, we will distribute. So if I put a 2 coefficient in front of this entire compound, what this is saying is that iron now has 2, and then sulfur now has 2 times this subscript of 2, so 4. And then we didn't change oxygen, so that's still 2.
Okay.
And then now I'm going to kind of look at where I'm at again, and I have my irons that are now balanced, but sulfur is not. So on this side, on the reactant side, there's 4. On the product side, there's only 1. So I have to put a 4 in front of this entire compound again. And then I'll distribute and recount everything up. So I didn't change anything on the iron, so that's still going to remain as 2. Sulfur now has 4. And then I have to re-add up all of the oxygens. So what I'm going to do is I'm going to distribute. So I'm multiplying this 4 times this 2, which gives us 8. Then I'm adding this to 3. So 8 plus 3 would give us 11. So now I have 11 oxygens. And then the last thing, as you can tell, is the oxygens. That's what I want to balance out. So with this one, it's a little bit, I guess, annoying because we don't have a, what am I saying? We don't have an even number.
Thing to multiply
yes,
it. Yeah,
exactly. So that's kind of the difficult part here. So instead, I'm going to just keep going and see what else I can do. Unfortunately, I can't just say, oh, this is 5. right? And that would give us 10, but it's not enough. It's not 11. So instead, we would have to, and really, I just now looking at it, I'm like, darn it, I didn't want to start with this one. We would have to, unfortunately, put a fraction. Yeah. So I know. I'm like looking at your face like, I'm sorry.
I thought we did away with fractions in algebra.
No. They come back. They come back in balancing, and they come back later in another section. But we would have to use a fraction. So instead, what I would do is, since I want oxygen to be 11, I'm going to say that this is an 11 halves. The reason why I'm doing this, the reason why I'm saying that this is a 2, it comes from this subscript. Okay, so if this were, and this is kind of crazy, but if this were like, I'm just going to say if this was sulfur, if this was an 8, then I would have said that this was 11/8. So it does come from whatever that subscript is, and typically it's going to be 2. That's just what I've honestly seen the majority of the time. So we're not done just yet. The last thing is we don't want fractions. We want to get rid of fractions. So if you remember, how to get rid of a fraction is by simply multiplying by its denominator. So 2 in this case. So I'm just going to clean this up real quick just to make this a little bit easier to tell. So if I were to try to get rid of that,
to do the whole thing.
Exactly. Yes. You have to multiply this every single one of these by 2. So every single coefficient. So this 2, and then this value. We didn't put any coefficient here, so I'm just going to assume it's a 1, and then this 4. So I literally have to distribute this to every single coefficient. So now, if I were to rewrite this is going to give me 4 for the first one. Then this 2, and actually I'm going to write it over here. 2 times 11 halves. These 2's would cancel. And that's the whole point of this. We want to get rid of that fraction. So now we have 11 O2, and then 2 again for Fe2O3. And lastly, 4 times 2 gives us 8 SO2.
Okay, that's not too terrible.
Okay, so I'd say this is probably one of the ugliest ones that you would see. I'm going to do another one with the fraction, but I would say the most difficult thing about balancing equations is if you have to use a fraction. And then as you can see, it's really just based off of, do I end with an odd amount of oxygens or even just an odd amount of an element? And there's no way to make it, the same. So then yes, I have to add a fraction.
Right. Okay.
Cool. All right. Next one. This one's easier. So this next part is, there's a trick for this. So if you note, we have OH and we have H2O. If I literally have to separate everything, that still works. Another way that you could have done this, and I want you to start getting used to, is separating any sort of polyatomic ions that we see on both sides. So there's actually a hidden polyatomic ion in water. We could have rewritten this as HOH. And then now we see, oh, there's that OH, and here's that OH. Do we see that?
Yes, but I don't understand how does that help us whenever we're balancing.
Yeah. So with bigger equations, with ones that I guess we'll see here in the next one, it makes it a lot faster, because sometimes we're going to have so many hydrogens, so many oxygens in different places, and to just be able to say, oh, I know how many OHs there are, that shortens the process.
Oh, I see what you're saying. Okay.
Yeah. So, but I still would have to say how many single H's are there and chlorines. So it just makes it faster, right? Because the main issue is oxygen. Oxygen takes, it can be a pain to balance, I'd say. That's why I always prefer to leave it at the end, or if I could use some sort of, trick, I will. So in this case, this is everything that we have. And once again, I still have to include hydrogen just because there's a hydrogen here and a hydrogen here that's left alone. That OH is only for what I highlighted. That's the only thing we can look at. Cool. So let's do this again for each side. So how much lead do we have?
1.
Cool. How many OHs?
2.
Perfect, because of this subscript. And then how many hydrogens?
Just 1.
Perfect. And chlorine?
1.
Good. What about the next side? How many lead?
Just 1.
Keep going.
And then 1 OH,
Good.
1 hydrogen, and 2 chlorine.
Perfect. Cool. So I would say in this case, you typically always want to leave hydrogen and then oxygen for the very last. So everything else, every other type of element, I'd say start off with that. So I'm not going to start off with balancing out the OHs. I'm going to start off with balancing out the chlorines. So how can I balance out the chlorines?
So we need to get it to 2. So we have to multiply by 2 on the left.
So we have to put it, you're saying this, right? Put a 2 coefficient in front of HCl?
Yes.
Okay.
Yeah, and then distribute it, right?
Exactly, good. Then just distribute it. Perfect, yeah. So that's exactly what we'll do. I'm going to recount again and just see, well, I know nothing else changed. The only thing that's changing is the amount of hydrogen and chlorine. So PB is still the same, OH is still the same, but now we have 2 hydrogens and 2 chlorines. So, okay, now I have to regroup and come back and say, all right, now how do I balance out the next thing? So the next thing I want to balance out is the hydrogen. And I'll leave the oxygen or OH to the very end. So how can we balance out the hydrogen on the product side?
By putting a 2 in front of the H2O.
Cool. Or we could also see it as, oh, it's 2 and H, like HOH, right? But this is going to distribute to both. Cool. So now I know, well, I didn't change anything on lead. And then how many OHs do we have?
2.
Good. How many hydrogens?
2.
Cool. And we didn't change anything on chlorine. And look at that. We're balanced.
Oh, wow. That took care of the whole thing. Okay.
Exactly. So it's a lot faster. That's why I typically prefer to do that if you can spot it. If for some reason you forget, and you do like what we were doing initially, it's still going to work. It's just going to take a little bit longer. Yeah.
So that's anytime you see H2O, you can write it like that and then cancel that way?
Yes. And this has to have an OH. Like one of these, has to have an OH to be able to do that because it has to be balanced, right? They have to have it on either side. Yeah. Cool.
Okay. Otherwise, it wouldn't help you anyway, right? I mean,
exactly.
if you did it.
Exactly.
Okay.
Cool. So then our final answer, I'm just going to show, I just want to reiterate that in case you don't see any number in front of, like a coefficient in front, assume it's just 1. Yeah.
Okay.
Cool. So that would be our answer. I'm going to keep going. Same concept here. So in this case, now we have a bunch of polyatomic ions in this case. If you could spot them, how many polyatomic ions do we have? I know.
We're going back before spring break
back.
right now. Wait a second.
Way back.
Polyatomic ions.
Yes, girl, you got an A.
Those.
Show me that.
Oh my gosh.
So, what's our first polyatomic ion that you can spot?
The H2O thing, right? We can make it.
Yes. Yes. Perfect.
We can do the thing.
What you just taught me, yes. Cool. What other one?
PO4.
Perfect. Phosphate, and then what other one? Just one more.
Like, thank God. And H4.
Good, ammonium. Okay, cool. So there are 3. So meaning I'm not going to separate any of those. I'm literally going to keep them the same to make our lives so much easier. So I have NH4, and then the other one we said we have OH, we have PO4, and the last thing that we also have that is not a polyatomic, I'm going to put this in purple, and not a polyatomic ion is our hydrogen here. So I will include that. So now this is going to be even faster. I really love using this trick because it seriously just makes this so much faster. So first off, let's just identify how much we have of everything. So how many ammoniums do we have on the left side, on the reactant side?
We have 4.
Hold on. So remember, NH4 is the entire polyatomic ion. There's no it's not in parentheses, and we don't have a subscript on the outside. So there's only 1.
1. Okay, yes.
Okay, yeah. Unlike this one, which has parentheses and a subscript, and that tells us that there are 3.
Okay.
Yeah, cool. But we'll keep going with the left side. So how many OHs do we have?
Just 1.
Good. And then phosphates?
Just 1.
Good. And hydrogen?
Just 1.
Hold on. So this one, we're looking at the 3 here. Right, for hydrogen?
Oh my gosh. Okay, yes.
Yes.
Sorry,
that
I'm
makes
kind
sense.
of like get used to like reading them like this. Okay, yeah, 3. All right, cool.
So then now looking at the other side, how many OHs do we have on the product side?
Okay, we have just 1.
Perfect. And PO4?
Just 1?
Yes, you're right, because there's no, this is not in parentheses, right? That 4 subscript goes along with the polyatomic ion. And that's what we wrote here, right? So it's not going to be 4. Cool. And then how many hydrogens?
Just 1.
Just 1. Perfect, because we're looking at this. Good.
Yes. Okay.
So then now we have 2 things to balance. I'd say I always like to leave hydrogen, like if I typically say, right, oxygen to the very end. If it's not that, then the other one you'd want to leave to the end is hydrogen. So now I'm going to just focus on ammonium to balance that out first. So how do we balance out ammonium?
So we're going to have to put a 3 on, like in front of the NH4OH.
Correct. So then now,
Okay.
Yes, perfect. This is going to distribute. I'm not going to look at like each individual element. I'm instead just going to look at each polyatomic ion. So I'm going to look at this and just say, okay, this now turns into 3 ammoniums. And I distribute this entirely to the OHs. So now there are 3 OHs.
Right, okay.
And then we didn't change anything else. So this is still 1 and a 3. Okay, so now this changes everything, right? Almost everything. So now I want to see, okay, what else do I have to do? Now we do have to balance out an oxygen. I'm going to leave that to the end. So I'm going to just now try to balance out the hydrogen. So how would we balance out hydrogen?
We would add a 3 in front of the hydrogen on the right.
Perfect. So I put this here, and I know that this is going to distribute to the hydrogen. So this is now 3, and it distributes to OH altogether, so there are 3 OHs. We didn't change anything else, right? That all remained the same, so we're done. Yeah.
That is so nice.
Exactly, yeah. It's so much faster. Like the other way, we would have been here for a lot longer.
Oh my gosh, yeah, this is so much better. And then it kind of teaches you to like read them, together the way they technically are.
Exactly. So perfect. That's all we'd have. And then I'm just going to put once again that these are 1s, coefficients in front. But that's it. I'd say that's one of the trickier ones too, just by looking at it if you don't know this trick. Okay. And actually, just to go over this again in practice, what type of reaction is this?
Let me see. Oh my gosh, I don't know. This is confusing. I see 2 of them combining and then another one with oxygen.
What else
but I
do we
don't
see?
have like the list of the things in front of me, so I don't know.
What do we see on the left side? What type of reactants do we have? Like HCl could be characterized as a what?
Oh, an acid.
There you go. Yes.
So an acid and a base and water and salt.
Mm-hmm.
Okay.
Mm-hmm. Yes. So yeah, this would have been an acid-base neutralization. Yeah, I know. So I'd say this one is probably the harder one to spot because you're not always constantly thinking like, hey, this is an acid, this is a base. But I want you to kind of get familiar with that, oh, this starts with an H, right? I have HCl, and then I have OH here as a base. Yeah. Cool. So what about this one?
Where's the OH going on the other side? There's nothing there.
It's forming a water.
HCl. Okay. Okay.
Right. So we have a water. Look at the reactants closely.
Okay.
Promise it's not a trick question.
I see an acid.
Yep. Good.
And a base.
Exactly.
It's the same thing.
It's the same thing. And this forms salt because, this is an ionic compound as well. The ammonium would have been positively charged. Phosphate is negatively charged. Then also forms a salt. So, and then this is water.
Okay.
Good. Cool. What type of reaction is this?
I can't remember the name of it, but the one where we, is this the synthesis or something?
It's not, because we have the same amount of, there's 2 reactants and 2 products, right? We didn't combine anything really.
Oh, we just switched it up.
Sure, but this is the one. I know where this is leading, and that's not correct. But this is the one where you could automatically tell based on it having an. Yes.
It's combustion.
It's combustion. Exactly. It's combustion because we have that O2 and CO2 and water. Yeah. So
okay, I totally just need to study the names.
Right. And then what everything is. I know. I'm just throwing this out there now. Let's go back to balancing. So for this one, there are no tricks up my sleeve here. There are no polyatomic ions that are on either side. So we're literally just going to do what we did in the very beginning, just writing everything out again. So these are all of our elements, and I think you get the point by now. So why don't we go ahead and start? So how many carbons do we have on the left side?
Okay. We have 4.
Good. And hydrogen?
Oh, thank God. I thought you were going to tell me. No, this substitute means something else this time. Okay. 10 hydrogens.
Good. And oxygen?
2.
Yes. Okay, on the right side, how many carbons?
Okay. Just 1.
Good. Hydrogen?
2.
Good. And oxygen?
3.
Good.
You were looking at me like, is she gonna add them?
I was like, wait for it. Cool. You didn't fall for it. I'm glad. Perfect. So I would say this is actually in the perfect order as to how you should balance this out. So always starting with basically any element other than hydrogen and oxygen. And then after that, after you balance that one out, then move on to the hydrogen, then move on to the oxygen for the very end. So let's start off with balancing out carbon. How would we balance out carbon?
We will have to put a 4 in front of the CO2 on the right.
Perfect. And then we know we're going to have to distribute to both of them. So how many carbons do we now have and how many oxygens?
So we have 4 carbons and 8 oxygens.
And then in total, how many oxygens do we now have?
Oh, yeah. 9, right?
9. Perfect.
Oh,
yeah,
no, we have to
No, you're right. You're right.
Oh, no.
So
we're not multiplying the other side. Yeah.
No,
we're just adding it.
Exactly.
Okay.
You only multiply whenever this number, this coefficient, to the subscript. So that gave us 8. And then we add, which is a key factor here, right? We're adding 1 oxygen. So 9.
Got it. Okay.
And then we didn't change anything on the hydrogens. So perfect. Carbon is now balanced. Now let's move on to hydrogen. So how do we balance out the hydrogens? Just going to clean this up.
Couldn't we multiply it by 5?
Perfect. And it's like we're working backwards. We're thinking, all right, we need to make 10. 2 times what value gives us 10? 5. Correct. So
Okay,
that's
cool.
good. I'm going to distribute again. So I'm going to ask the same question. How many hydrogens do we now have? And how many in total oxygens do we have? In total.
So we have 10 hydrogens, but for the oxygens, I'm going to do, like, I'm going to have to use the new number, or I'm still using what we have up at the top. So I'm going to do like 8 plus 5.
Correct. We always look at the top. So we're not adding on to whatever we found previously. You're always going to redo it looking back at the equation.
Okay. So 13.
Cool.
Quick math.
Good. Perfect. So sadly that didn't, and the carbon stayed the same. Sadly, we are not balanced and we have an odd number. Bum, bum, bum. So
fraction time.
Fractions. Yes. So I know I have to put what in front of the O2? What fraction?
Okay. We're going to put a 13 over 2.
Good.
13 halves.
Perfect. And we know, I'm just going to reiterate this. I know the 13 is coming from whatever I want the oxygen to be. And I know that 2 is coming from this subscript here. That's my denominator.
Yes.
Perfect. Cool. And then when we do that, our final step is to simply multiply the entire reaction by 2 to get rid of this denominator. So here's a 1, and I'm just going to distribute everything and rewrite this out.
Okay.
So our final answer would be 2 in front of this first 1, and then next we know that this 2 and this 2 would cancel. So I know that this is 13O2. Now I'm not going to look at the canceled part anymore, and I'm going to relook at this and say, okay, 2 times 4 gives us 8 CO2s, and then 2 times that 5 gives us 10 H2Os. And that would be our final answer.
So we don't do anything with the new numbers that we got at that point. Like at the very end, we're just looking at the original thing at the top.
What do you mean the new numbers? Like these?
Yeah,
Or,
like all those.
Got it. So the whole point of like writing this out was just to figure out what coefficients we need to put in front.
Okay.
Yeah, we don't do anything else with those numbers. Yeah.
Okay, cool.
Hey, sometimes I know that not everything clicks immediately, and that's okay. That's why there's a replay button. So if you need to rewatch this, please do so. You're allowed to do that. Take some notes and keep practicing because you will get through this.